Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 7, Section 2, Representing Linear Functions. Or another way to word it would be representing linear equations, because that's what we're really going to be doing. When you have a linear function, which is a function that when graphed, a linear function is a function that when graphed makes a straight line. And if you recall correctly, a function is a group of ordered pair, okay? So it's a group of ordered pairs, so having multiple ordered pair, where you have a special relationship between the x-coordinate and the y-coordinate in each ordered pair. So for example, that relationship might be that the x-coordinate is twice as big as y, or the y-coordinate is twice as big as x, or it could be something more complicated. Now, when you have that special relationship or pattern between your x and y coordinates, you can create an equation. And that's what we mean when we are representing linear equations. That's what we mean when we're representing linear functions. Okay, we're taking a function, such as this one, and we're going to represent it with an equation. So this is a function, this is a group of ordered pair. I have three ordered pair here. And there is a special relationship between them. And I can represent that as a function or as an equation. So I'm going to represent this special function as an equation. And in this case, the function is really easy to identify. And I made it that way on purpose. A lot of times it's going to be very difficult to identify what the special pattern is. In other words, what is happening to x to get you y? Because remember, the x column is also known as the input column, and the y column is also known as the output column. So when we input x into our equation, what happens to it that gets us y? In this case, when I input x, it's multiplied by 2. And that's how I get y. And this is how I represent my linear function. I represent my linear function with a linear equation. So what is a linear equation? How can we look at an equation and know that it's a linear equation? That's going to be what we're going to focus on in this video. Okay. So to represent a linear function, you have to be able to turn it into a linear equation. Now, the way you can identify a linear equation just by looking at it is you're looking for three things. If you have a linear equation, then you have two different variables. So x and y, a and b, c and d. You can't have a and a, you have to have two different variables. You have to have your variables in separate terms. Okay? Your variables need to be in separate terms. And what that means is, essentially what that means is you need to have some sort of sign or symbol between them. So I might have 3x plus 4y equals 7. That the x and the y are in different terms because there's a plus sign between them. I might have 3x plus 4 equals y. The variables are in separate terms here as well because there's an equal sign between them. There's also a plus sign between them as well. You might see 3x minus 4y equals 8. Okay, again, there's a subtraction sign between them. So there's something between them. That's what puts them in separate terms. There's nothing between the 3 and the x, so the 3 and the x are in the same term. So an example of an equation that would not be linear, okay, if I had 4xy plus 2x equals 8. This would not be linear because the x and the y are in the same term. And you also have two of the same. but the big thing is x and y are in the same term. So that would not be a linear function or linear equation. 4x plus 2x equals 8. This would not be a linear function because there are not two different variables. 4x plus 2x would get you 6x. So we would simplify that into this. And at this point, we don't have two variables. You have to have two different variables, and they have to be in separate terms. And the last thing is that neither variable can have an exponent. Aside from 1. So how do you know if your variable has an exponent of 1 or not? Well, if you don't see an exponent, your variable does not. If you don't see an exponent, your variable has an exponent of 1. So x, you don't see an exponent here, that's because x is to the first power. We never write to the first power, because x to the first power is equal to x, so there's no point in putting the 1 there. So if you don't see any exponents on your variables, then you're all good. So for example, 3x plus 2y equals 7. Two different variables. They're in separate terms. They're separated by a plus sign. There are no exponents that I can see, so therefore they have exponents of 1. So life is good. However, if I had 3x squared, this would not be a linear function. It is a function, but it wouldn't be one that makes a straight line. That's something we'll discuss later in the chapter. So if you didn't get a chance to write that down, you might want to pause or rewind the video, write it down. But that is essentially how to identify a linear function. Tune in for the next video.